So here's part one of fiber analysis and forensics. So you may not think that fibers can be useful for forensics investigators. However, many cases have been solved through fiber analysis. So what exactly is a fiber? You guys looked at this, you did your web quest, so you should know that a fiber, when it comes to forensics and evidence and stuff, not in cereal or anything like that, like the actual fibers in textiles, they are the smallest individual unit of a textile, whereas a textile is a flexible flat material made by interlacing yarns or threads. So fibers often fall off and are picked up during normal activities. And this goes along with Lockhardt's principle saying that you leave bits of yourself when you go somewhere. Like everybody leaves a trace of themselves. So very small fibers can easily shed from most textiles and can become trace evidence, all right? Fiber evidence can show such things such as the type of fiber, its color, the possibility of violence, location of suspects, and even point to the origin. So transfers of fiber. So you have direct transfer and then you've got secondary transfer. So direct transfer, that's fibers that transfer directly from victim to suspect to victim. For instance, jacket fiber from a suspect is transferred to the body of a victim. It could even be like I'm sitting in this chair and a little bit of my shirt comes off and the fiber's on this. So that's a direct transfer. Now there's a secondary transfer. So say I was to do that and then somebody was to move my chair out of my room and put it somewhere else. And then somebody sat in it and then picked up the fiber that came off my shirt. They sat in it and they went off somewhere else. That's secondary because fibers can be transferred from a source, like the chair, to a suspect then to the victim, or from a source to a victim and then to the suspect. So like I would sit back, fiber gets on the chair. My chair gets moved somewhere else and a random somebody comes sit down in my chair. They lean back and they've got now the fiber on them and they go off. That's secondary transfer. So another example is carpet fibers from a suspect's house transferred to a suspect who then transfers it to the victim's clothing. So collecting fibers, how do we do them? Well, you use a vacuum, adhesive removal, or forceps. Adhesive removal, that could even be the little lint roller type thing. It could easily be masking tape just set against it and pulled back. And now we get to classifying. So you have two types of classifications. You've got natural, you've got synthetic. So natural comes from like animals, plants, minerals. I'd like to say organic, but it's not all organic because minerals aren't organic. But it's all natural. It's not man-made. It's nature-made. Then you have synthetic. This is the man-made stuff. It's produced in labs, and they are produced by joining monomers together to form polymers. Monomers, that's one, to polymers, many. So a couple types of the natural is a plant fiber. Plant fibers absorb water. They're insoluble. That means they won't dissolve. Like my shirt's cotton. If I throw it in water, it's not going to dissolve. I still have my shirt. They're resistant to damages from harsh chemicals. So sometimes it's a lot harder to bleach a hole in it with chemicals. Can only be dissolved by strong acids. That's where that bleach came in. Like acids or bleach is a really strong acid. So it can dissolve a little bit, but it is a little bit more resistant to, say, if you dropped a little tiny bit of bleach on something else, synthetic, it could burn a hole straight through it. It can be common at crime scenes because they become brittle over time. And some examples are cotton, core, or hemp. Animal fibers. So this is like wool from sheep, cashmere, angora, and even silk from caterpillar cocoons. And you can see some of them right here. You've got wool, the scratchy wool, cashmere, and then silk. And then you've got some mineral fibers. Not usually something you wear, but you can find them in like fiberglass. That's a fibrous form of glass. That's why when you they highly suggest you wear gloves and stuff when you're dealing with fiberglass because you can get it on you. They used to use asbestos quite a bit, and that's naturally occurring. The bad thing about that is it can get stuck in your lungs, and it's really, really bad. You can't get it out anymore. Then you come to synthetic, where you've got some polyester, nylon, acrylic, acetate, and rayon or viscose. So polyester found in polar fleece. It's usually wrinkle resistant, not easily broken down by light or concentrated acids. And it's typically added to natural fibers to strengthen it up. Then you've got nylon. Nylon is, I'm missing these things right here, right down here. Okay, so here's some polyester. Here's some nylon. It's easily broken down by light and concentrated acid, so not that great. Otherwise, it's very similar to polyester. You've got acrylic. It tends to ball easily, used in artificial wool or fur. We don't have any acrylic right here, but we do have acetate. This is kind of silky-ish. Dries easily, resists absorbing moisture. Rayon or viscose. It's semi-synthetic with a high luster and bright sheen. And as you can see, like yarn. All right, so today, not today, but on Wednesday, you guys are going to be reading about the Atlanta child's murder. It's not going to look like this. It's going to be a more in-depth one. And then you're going to watch a video. I've broken it into 3 parts. And you're going to watch that if you choose to. But you will definitely have the reading. And that's going to be on Wednesday. If you have any questions, please let me know. And I hope you guys have a great day.